Kia ora koutou katoa. So I'm Lennon Bedford, reality capture specialist at Global Survey. Right, today I'm very excited to have another member presenting some learnings from a key project. So Graham Watson from Road Science is going to be speaking to us today about a recent project he had the pleasure of carrying out over the ditch at the Bathurst Racetrack. Please feel free to be part of the webinar today by submitting questions. Please use the tab in the GoToWebinar platform, the questions tab. I'll collate those and then fire them at Graham at the conclusion of his presentation. And I'll finish off today with some highlighting some events that are coming up that are relevant to the community. So without further ado, I'd like to introduce Graham. Graham doesn't need much introduction. He's a well-known member of the reality capture community here in New Zealand. So an early adopter of reality capture tech in the surveying space here in New Zealand. I've been working with Graham since the early days of the P40 at Opus, as the company was known in those days. Opus were one of the first to buy a P-series device and deploy it in New Zealand. And when I think back to those days, one of the first to mount it on a vehicle using the Scan and Go platform. So not a mobile mapping platform, but a stop and go vehicle mounted system. And that was, a clever way of keeping boots off the ground, people out of live traffic lanes. You could scan from the safety of the cab. And yeah, since those days, Graham has now moved on to Road Science and manages the mobile mapping division there with the Leica Pegasus system. So the first mobile mapper in New Zealand. And he's been doing that for close to 6 years now. So he's built up a wealth of knowledge with mobile mapping at the survey grade end of the spectrum. And today he's going to speak about the opportunity he had to fly across the Tasman and hire and test the latest generation Leica mobile mapping system, the Pegasus TRK. And so, yeah, drawing on his wealth of knowledge with the previous system, he's able to, be in a really qualified position to compare and contrast the system, the usability, the capture, and then the quality of the results at the other end. So without further ado, I'm going to hand over to Graham, and I look forward to seeing what he has to say.
Bathurst and a new toy, a very interesting trip. So a colleague and I fought over this. I won because she'd already been to do a job earlier in Brisbane, and I got the job of going to look at Mount Panorama and to try out the TRK 700 Neo. Mount Panorama, for those that don't know, of course, is home of the Bathurst 2000 supercars. It is also a public road, open every day, so that people get the chance to whip round it. I thought it would be quite busy, but it was actually very quiet. And I spent a couple of days in Bathurst doing the town main street, as well as a couple of jobs for the local depot, down the depot there. Okay, so the main reasons for the trip were the Bathurst Racetrack survey, which was mainly a marketing for Downer to present to Bathurst District Council for the racetrack, a chance for us to do some overall MLS marketing to the Downer community, and also for my personal to try out the TRK and compare it to what we already have now. Okie doke. The new toy. This is the Leica TRK Neo 700, which we hired from CR Kennedy in Melbourne and Sydney. And in this case, the one that we trialed had twin scanners. I'll just do a quick comparison with what we have. Our Pegasus 2 Ultimate, which has a ZNF scanner, and the 700 has twin scanners that are scanning at twice the speed. So the Pegasus is doing 1 million points a second, and the 700 is collecting 400 million because of the two scanners. It also has SLAM technology to aid in GPS challenged areas, and also is RTK capable. We didn't have an chance to try the RTK, and however, from a personal point of view, post-processing still always seems to be the best solution. So the other major factor is that our Pegasus 2 is 50 kgs and the TRK is only about 20. So it is much more manageable. What you get in the box is lots of them. So there's 8 cameras that are attachable, and they can be in landscape or portrait mode. The tablet to run the whole system. This unit here is a Neo 500 because it's only got one scanner. The bracket to hold it on top of the vehicle, and the control box and the battery. As you saw in the video, it was all quite nicely laid out in the back of the vehicle. In my case, it was much harder because I still had all the boxes. So this is what you see on the ads, and this is what you don't see in the ads. So the whole system actually came on 2 pallets, where we managed to, with a bit of Tetris experience, to get it all into the back of the vehicle with the seats down. So not useful for a small car unless you've got somewhere to store all the boxes. I apologize in advance that I didn't realize I was going to be doing this. So when I was over there, I didn't take as many photos of me setting the thing up as I would have liked, or should have done really. So this is the one that was assembled in Brisbane for the airport. And this is on a RAV4 with the roof racks attached to the top because it had roof rails. So it was easy to put the frame on, and then you slide the unit up onto the vehicle. This is the vehicle that I had, which is still a RAV4, but had no roof rails. So we spent a whole day driving around Sydney getting roof racks and attachments for it. Apparently you can't hire a car with roof racks. The hire companies won't let you. So we had a mad day of charging around to get it mounted before we could do any work. When it was finally up, this is what it looked like, all ready to roll. It was very easy to get it on. It's very simple for 2 people, quite hard for 1. I managed to get it up on my own the first time, but after that I decided it was too expensive to lift up on my own. So 2 of us got it on, and it's very simply, it clips on and it mounts very easily. And once assembled, the tablet, you scan the QR code that's on the control box, and it starts up the tablet, and away you go. Really, it's as simple as that. I'd like to say it went really well, but it took 2 or 3 phone calls back to CRK to get it to work. That seems to me a usual tech problem, and the answer basically ended up as being turn it on, turn it off again, and that seemed to work. So I'd like to thank Sam Hesper for CRK for all his assistance while I was fiddling about with this. But once it was going, it was easy to use, very, very simple. And this is what we were looking at. These are the 2 missions that we ran for this. This was day 1. So we did the approach into the racetrack and up the hill, and then we went around the racetrack actually 3 times. The post-processing was done from the Bathurst cause station, which, as you can see, is very close to the racetrack. This was the trajectory that we calculated from the runs. This was all done in Pegasus Office. We did not have any ground control. It wasn't required for what we were doing. So day one, yes, we did 3 passes around, and on the second day when I did another one, which we'll show later, I managed to go around without seeing another vehicle in the hole, which was quite nice. But of course, because it's a public road, we could drive around quite slowly, and that allowed to get good data sets. So this is the day 2 data, and it was all done in a single pass, and I didn't drive at this speed. Examination and reports. So the cutting, which is what I've concentrated on here, the top right shows the crown lines around the bend. The track is of course highly super elevated around these curves and bends, and the road conditioning tool is primarily designed for urban roads, which are flat road surfaces. So in this case, we ended up having to examine the cross sections to create the crown lines to get good results, to make sure that the road conditioning actually resembled what the track looked like, and not make it look like it was a mountain or a big lumps. And the left one shows the AutoCAD drawing, PDF from the AutoCAD drawing, which shows the areas of interest on the track. And one of the things that they were highly interested in was the resealing. These darker patches on the track are cracks in the road that have been sealed over over time, and this is what they're looking at examining, and in which areas they might need to do more intensive work. So on the right hand side, I isolated all those cracking in 3DR by intensity, and this allowed me to create a new point cloud purely of all the point of the ceiling. And then in TopoDot, we managed to create areas from these point clouds to indicate how much area of the track was actually they had resealed. And there is quite a lot of this around the whole length of the track. From these, we produced PCR reports, pavement cracking index reports, which is based on the American ASTM standards. We did it in 100-meter sample units, and as you can see from on the left-hand side, areas were good, satisfactory, and this is just based on a calculation done based on, as I said, the ASTM standards, which is the American Society of Testing and Measurement. And the PCI reports are an international standard, but so we just produce those for them, and also then we produce section reports along the track to show the shape of the track as it was around going around. So we did this for those 3 areas as a concentration. One of the aspects I think that the people didn't realize who we were dealing with was how much data you actually collect by MLS, by the mobile scanning, and they all sort of thought they were just going to get the track and that would be it, and absolutely staggered to see how much more information, usable information, you can collect just by driving around the track for what takes basically half an hour to drive around if you're doing 40 Ks and getting really good information. So for the final deliverables for us for this job, we produced the point clouds for them. We gave them the Excel spreadsheets, which had the PCI reports. There's another spreadsheet that just shows the distress information for each area. And then we did cross-section reports. We gave them AutoCAD drawings as well. And we also gave them a viewer file, LGSX, which is the proprietary Leica viewer, which runs in TrueView, which allows to see the point cloud and all the imagery, including all the side cameras and the pavement cameras. And we also supplied MP4 videos. But my final thoughts are that it was a great trip. The weather was great. The job was very interesting. The TRK was an interesting experience. As I said, fantastic piece of kit, you know, half the weight of ours, but also twice the price. So there's a few things you have to consider. It was a fantastic data set to work with after we collected it. The data set from the TRK was fantastic. I have to say that the data was really good, and the people we work with in Australia could not have been more helpful, and hopefully we'll have more trips. So just to finish off, this is one of the videos that we supplied at the end, and this was the one that they really liked the most because it showed all the information they wanted on the track. While the viewer file is more complete, they found this easier to manage because they didn't have to install anything. They could just run this, and of course, because they know their way around the track, they knew where everything was. So
vehicle driving along at road speeds. It's incredible. For me, a couple of key takeaways, like it's amazing the value of the intensity returns from a scanner, and the applications you wouldn't really think about. So those, sealing and the cracks, like they just stand out like a sore thumb in the intensity view, and then using the segmentation within 3DR is so simple to isolate those areas. And then seeing the power of a simple video, because it's always a challenge delivering this amount of data onto your end client. And so interesting to hear the value the customer, identified in a simple video. As you said, they know the track, so they can relate the video to the real world really simply. So yeah, cool to see. Got a series of questions here.
Yeah. Go for it.
Let me see where to start. And how did you? What criteria goes into like defining the speed that you drive the car at? Like, what's the maximum speed you've ever captured a data set at, and how do you make that decision?
Well, it works on the theory on the Pegasus. Basically, 10 Ks is about 10 mil for profiling for point distance. We generally try. If I had my way, I'd be doing 40 Ks, I think, for everything. But obviously on the open road, it's not possible. So we generally try to stay to 50. If we're on main highways where it's 100 Ks, then it's a case of doing what you can and then doing multiple passes, I think, is the way you would go. But to be fair, quite often we found it quite easy to keep the speed down. We haven't had, I don't think we've had any incidents where we have people right behind us, getting really frustrated. If a queue starts to develop, we pull over and stop, because it's better to stop than to slow down and speed up. So we've found that that's definitely a policy we would adopt. If we're starting to cause a few delays, we would pull over completely, because the scanner, while it's static and scanning, it cleans out the data, so you don't end up with thick lines. But if you slow down and speed up, you end up with sort of slightly different densities of scanning as you go along. So try to keep it like the Bathurst, because there was the second run I did at 40 Ks, and what I've tried to do is often try to set the cruise control, because then that's the easiest way. So and it is governed by what you're actually trying to do as well. Like if you've got open road and it's edge of sea, or if you've got curb and channel and things, you want to be going slower than if you've got just open roads and what you're doing. Like if we're interested in just say vegetation and things, then you could do 60 or 70 Ks. It's not going to make, when you consider that a normal survey would be 20-meter cross sections and you're getting points every 70 millimeters, I don't think it really, it's sort of, you have to talk to yourself and actually say, hang on, I'm catching so much information here compared to what I would do. It's like when a car goes past, you think, oh, there's going to be a gap in the data, and you sort of look, there's a 300 millimeter gap in data that it would normally be 20 meters apart. So I think you have to bear that in mind all the time, that you're collecting so much information. And it will always have its restrictions for things like vegetation and stuff. But so generally 50 Ks would be what you try. And of course, with the speed limit still, well, going back up now, but coming down, of course, through towns, it's never such an issue. It's just on the open highway that it becomes more. The decision has to be, you have to look at what you're working within.
Other question, I could look pretty open in terms of GNSS sky visibility. Do you think the SLAM helped much in automating or refining the trajectory of the point cloud in this case?
No, not at all. We didn't use it, and the suggestion was not to use it. I talked to support at Leica, who said that no, it wouldn't. I think the SLAM is really designed for urban built-up areas where you've got vertical
tunnels.
Yeah, and vertical surfaces, you know, and where the track is just trees. You know, so you on the trajectory you could see the very small pieces of red where the trajectory had struggled, but that, you know, again, if you're going at a 50 k's an hour, they're not very long, so the outages are quite short, and the IMU can cope with those. So we didn't bother with a second antenna either, which that would be the other option. But I think, yeah, it's interesting with the SLAM and the RTK that, you know, that it seems like it's available, but would you use it? I don't know. You know, I mean, maybe if you, depending what you were collecting for the RTK, again, if you were doing things like, say, vegetation and just visualization, then maybe the RTK would be quite easy. But over here, I mean, one of the problems is, of course, that having RTK available, it'll get better, I suppose, with Starlink and stuff like that. But you know, there's more cause stations in Australia than say here, so maybe it'd be better. It would have been interesting to have tried the RTK at Bathurst, but I said it became a license issue because we hired the equipment. We don't have any of those SmartFix or equivalent licenses over there.
Did you collect the data in both directions or just one direction?
One direction, because you can only go in one direction. Right. I think. I've got a feeling they don't like you going the other way. But we did only do it in one direction. We could have done it in both, but with dual scanners, I didn't think it was quite as essential. But yeah. And for what we were interested in, we weren't really interested in we were interested in the track, not so much the trees and stuff like that. I think, yeah, we would have done, depending what the work was done, we might have gone in both directions. But I can't remember if they don't like you going the other way. I've got a feeling that was one of the reasons, that you have to go around the track the way the road is. I'm not sure.
Right.
Or I'm not sure if it is. It might be. I think it might be suggested. It might not be, against the law. But I think that everybody tends to go the way that the race goes. It sort of gets in your head. That's the way you should go, because that's the way the race goes, I think.
And you mentioned that ground control wasn't required for this one. When you are chasing the higher absolute accuracies, what sort of spacing do you use for your ground control?
Again, this is dependent on sites, I think. For open highways, we're looking at 300 meters as sort of 300 to 500 meters maximum. And especially open, if it's open ground. But if things get tighter, then I think you just have to review the situation on what the site is, you know, because I've heard say that, you know, sometimes if you're going through an urban, you know, like if you were doing Wellington, should be looking every 30 or 50 meters to have stuff so that you've got ground control to support everything. You know, same as, say, going through a tunnel, you want ground control really tight to keep it. Keep the control within, but I think, yeah, dependent on sites and what the job, you know, what's on the site and what they're looking to do with the site, I think. So we tend to look at it on a site-by-site basis.
Yep, makes sense. I guess time for one more question. Having come from terrestrial laser scanning and moved into mobile mapping, you had experiencing, you know, a lot of the challenges with reality capture, you know, managing the data and things like that are similar. What's been the biggest challenge or learning curve moving to mobile scanning?
I think probably the data storage is still one of the big things. Data storage, and also sharing data visually. And I'd say one of the biggest challenges is still trying to get people to use the data for, you know, the amount of data that you collect, and getting them to use it. You know, that it's still frustrating to find you collect all this information and all they want is a AutoCAD drawing. You know, but when they've got all this information and they don't really know what to do, and we're constantly working on the education of trying to say to people, why don't you look at this data, and that's where one of the aspects of sharing the data visually is such a problem, because a lot of places now, they can't install software, so you need a platform that can basically be streamed. I think that's why we've been looking at reality capture, studio capture, and that sort of thing to try and find a solution, because and a cost-effective one. That's the other thing. It's trying to find something that's and like you, the thing that staggers me about having come from the terrestrial world, the scan data is interesting. The fact that the data coming off a vehicle that's bouncing around at doing 50 kilometers an hour is as good as it is still, I'm still blown away every time I look at, like you, every time you look at a data set, it's hard to believe it came off a vehicle that was, especially if you, and not even so much the stuff off a road, but when you're doing gravel tracks and stuff like that, it's incredible that it can actually produce what it produces. So, but I think still data storage and management is probably still the toughest thing for all that stuff.
Yep, good stuff. All right, hey, thanks very much for all the questions.
If anybody's got any questions, I'm quite happy if they email me, and I'll answer any other questions of them.
Thank you. All right, so just looking forward, the next event is being run by Kirsty and myself. We're just going to give a bit of an update to those of you using the flagship Leica scanning softwares, Register 360 and Cyclone 3DR. There's been some significant updates released this year, and we're just going to highlight some of the key features and the value they present. So that's coming up on 26th of August. You can sign up on our Arch NZ website. Also relevant for the audience here is some demo days we're running on some autonomous survey tech. So Auckland was last week, but coming up tomorrow in Christchurch, we actually have an event in Timaru, if anyone's in Timaru, on Tuesday, and then next Thursday down in Dunedin. So I'd love to see you there. And then building on that, a deeper dive into the workflows is a pre-conference workshop. So anyone heading to Christchurch to the Survey and Spatial conference in September, we're running a pre-conference workshop on the day before in the spectacular Avon room at the Christchurch Town Hall. So we'll be looking at over the Avon, amazing space, and looking at autonomous USVs for hydro, LiDAR from CHCNav, and some handheld SLAM tech, and how all those data sets can be merged into a single model using the Cyclone 3DR software. So I'd love to see you there. And I think we'll close things there. Thanks very much for joining. Again, please feel free to get in contact if you have a project you'd like to present. Firm believer, and we're all stronger by sharing, stronger together by sharing all our work. So love to hear from you. Catch you next time. Ka kite.